How you guys doing?
My name is George. I am going to be answering question 5. Start with question 5a. Given limit of 42 as x approaches 3. Now, using the limit definition of the derivative, we know the limit of a constant is just 0. So it's just 0. And that's something that you should all have memorized. The next question, we have the limit secant of x as x approaches negative pi over 2 from the left side. Now, let's visualize what the secant graph looks like. All right. So at 1 and -1, you're going to have the vertices, which are going to be pi, every pi. So this one's going to get greater. That's a 1, by the way. I know you can't really tell, but this is a -1. This is pi. And this is negative pi. So these are the vertices of the parabolas that go down like this. All right, and we are going to have a vertical asymptote at pi over 2 and at negative pi over 2. That is what the secant graph is going to look like. So, the limit of secant x as x is approaching negative pi over 2 from the left side. Now this is negative pi over 2. This is the x value that we have the asymptote at. So this negative, it doesn't mean that the pi or this entire thing is negative. It's not going to be a double positive. It means that you are approaching x from the left side. You're approaching this value from the left side. So as you are getting closer and closer, infinitely closer to negative pi over 2, you are approaching this asymptote. You're not touching it. So this parabola is going to approach negative infinity down here at the bottom. So knowing that, it has a vertical asymptote at x is equal to negative pi over 2, the limit of secant of x as x approaches negative pi over 2 from the left side is equal to negative infinity, because it will keep decreasing infinitely as it gets closer, like lower down here. It'll keep going. Okay. For our last question, make sure you guys can still see that, we have the limit as x approaches 11 over 6 from the right side. Sorry, oh my god, it's been a long day, guys. The limit of the function 32x over 11 minus 6x as x approaches 11 over 6 from the right side. Now, if we do direct substitution, we do 32 times 11 over 6 over 11 minus 6 times 11 over 6. This is going to end up being 11 minus 11. So this is going to be 0, which is indeterminate. So we're not going to find the derivative that way, or the limit that way. So what would help, I'll make it a little bit bigger, would be to visualize it. So we know that x cannot exist. X is indeterminate at x equals 11 over 6. So 11 over 6, let's just put it over here. That's our vertical asymptote. Okay? I'll do 11 over 6. All right then. So let's see what happens as x gets larger. So as you keep increasing, let's see, if you look at 11 over 6 from the right side, it's going to approach it. So this number is getting smaller because it is going towards the left side. We're going to be approaching from the right. So we're approaching 11 over 6 from the right side. That's this direction. So this number is actually getting smaller and smaller and smaller. It's greater than 0 because it has to be greater than 11 over 6. But it's still getting smaller and smaller. Greater than 1, but smaller. So if this number is getting smaller and this number is greater than 1, it is going to keep going down infinitely, like that. And this would look inverse as well. All right, that's an exaggeration. I don't know what the actual graph looks like, but it would look something like that. Okay, so knowing that, we could see, all right, as x is approaching 11 over 6 from the right side, we are going to go infinitely down to negative infinity. So because we have a vertical asymptote at x equal to 11 over 6, limit of the function 32x over 11 minus 6x as x approaches 11 over 6 from the right is equal to negative infinity. That is our final answer. All right, I really hope that you guys could see everything and that the quality came out well.